Okay, here's our next one. We're going to do the same integral, the one we just did. Remember, this is the same one, number 5. Same one. And let's see what happens. We're using a different substitution this time, though. And we're working with this form here. X is going to be the sinh of u. So we'll need a dx, which is a cosh of u du. And now we have to find this expression. So once again, I'm going to do it the same way, x squared, and then 1 plus that. Now you have to remember that we just talked about this. Well, there's a reason why I kind of stuck that in there. That first identity that we had this one. Because we're going to use it here. Just moving that sinh over, we get this. Which means I can replace over here cosh squared for that. Which means over here now I have my dx, which is cosh u du. And underneath I have square root of this cosh squared, which becomes just cosh u over cosh u. And again, I don't have to worry about sign changes in here. I'm always worried, have I changed the sign of my integrand? And I didn't so far, because the cosh is a positive function everywhere. So no worries about changing this square root of cosh squared and ending up with a negative quantity, because that can't happen. All right, that's just a 1. And you can't ask for a better substitution. I mean, look what we have there, a 1. So it's a u. Whoops. Equals there. I don't need that. Okay, so we have u plus a constant. And now we're going to put that u back in, but we need to do a little something here with this. Okay, now we know the inverse exists, so solving this for u is going to give us that u equals the inverse hyperbolic sign. Okay, assuming that that this function exists, and we know it does, even if we don't have an explicit description of it. Okay, so that means over here now we have this plus a constant. So if you take these two results together, what we're showing is that whatever this is, it must be the same as this within the constant. Okay, same expression within this additive constant, because two functions who have the same antiderivative they can differ by no more than a constant. Okay, that the antiderivatives of the same function can differ by no more than a constant. That's what we're saying here. So this says basically that the sinh, hyperbolic sinh, plus that constant is going to be equal to the same what we have here, plus x squared plus that x. Okay, and that's plus a constant. Now, the whole point here is that we don't need the two constants. We can lump them together. They're just unknowns anyway. And so I'll remove that one. But the point is, I still want to know what is C, if this is going to be true. Is it some number other than 0? Is it a 1? What is it? Well, we can use our minimal knowledge that we have. I'll put a 0 in here, evaluate this for 0. And this side, I'll evaluate it also at 0. 1 plus 0 plus a 0. Okay, so this right-hand side is just natural log of 1, which we know is a 0. Okay, and this side over here, we know this is 0. We know it's a 0 because look at the graph up here. We don't really know any other values here. We haven't calculated any, but we could see for sure that 0, 0 is a point on both curves. So we know the inverse sine of 0 is a 0. So back here, then we have that 0, and that means C is 0. So all in all, what it's saying is that we now have a formula for the inverse sine, inverse hyperbolic sine. And it's this right here. This is our definition. Now you could find this also just by using, I mentioned this earlier, I think. You could find the same expression if you just started with this. Okay, and then said, you know, okay, I know this thing exists. This is 1/2 e to the x minus e to the negative x. Oops. And that's why if you switch the x and y, we can actually solve this for y. That's a little bit of a challenge for you, but if you do so, you're going to end up with the same expression we have here. Now, a word about this, the absolute value bars here. If you look at this closely, the square root of the x squared plus 1, that is always going to be bigger than this number here. Okay, if they're both positive, it's going to be true. If x is negative, then this expression becomes negative, but it's a little bit smaller in magnitude than this expression because of the 1. So what you have in here then would be overall a number that's positive. Okay, so you really wouldn't need the absolute value bars. Okay. So for that reason, you might see when you get to all these are listed in the textbook. When you get there, you're going to see those bars removed. That you won't see them. I've got them listed here, but and of course we determined already that C is a 0. But you'll see this in your listings. It'll just be natural log of x plus square root of 1 plus x squared, like that. Okay, you don't need the bars. We didn't know that when we integrated, so, but now we've analyzed it and we know that. Okay, so that's trying to put those two results together.